So this video is for your lesson for today, and it is on finding zeros of polynomials. So we're going to take what we learned about the division, the synthetic and long division, and just go a step further and actually find all of our answers. So first, your fundamental theorem of algebra states that the degree of a polynomial equals the number of complex solutions. The word complex doesn't mean it's like complicated. Complex means both the real and imaginary ones. So just all of them. So the degree is your highest power. Whatever that highest power is, that's the number of answers you're going to get. So for this one, we're going to get 4 answers. For this one, we're going to get 4 answers. For this one, we're going to get 3 answers, so on and so forth. So that power tells you how many answers you should get. Now we're going to need the calculator to get us started with the first one, unless you just want to sit here and guess all day what one of your zeros is. So I'm sharing my screen. I'm going to type in that first problem. Right? And then I'm going to click on one of the zeros and I see that it is 4. So 4 is one of my answers. So when I go to do my synthetic division, 4 goes in the little box. Now here's the really great thing about this. If 4 is one of the zeros, our remainder will be 0. So it's like you know the answer to the question before you even start. The remainder is going to be 0. If you do not get 0, you have done goofed and you need to go back and find where you dropped a negative sign or something. So our exponents are in descending order. I'm just going to steal all these numbers, the coefficients, and I will end up with 0. I'm going to do this pretty quick because it's just multiplying and adding. And we just did a whole, practice worksheet on it. So you should be able to get through that part pretty quick. All right, so one of my answers is 4. I need to go back and find another one. So let me share my screen again. So I'm going to click on this one. That is -1/2. So in the little box, I'm going to put -1/2. And we're going to keep going. So I'm going to bring down the 2 and then multiply, add until we get to the end. So that'll be -1, 0. Anything times 0 is 0. It's 2, -1. And again, I got a remainder of 0. You should get a remainder of 0. If you don't, then you had an issue somewhere. So this is one answer. This is a second answer, but I should end up with a total of 4. When we look at this graph, you can see that there aren't any other real zeros. This doesn't touch the x-axis anywhere else. What that means is my other 2 answers are going to be imaginary. So when I go to put the x's back in, usually you start with 1 less than your degree. We're actually going to start with 2 less because we divided out twice. I hope that makes sense. We divided out twice. So I'm actually going to start with x squared. So we're going to have 2x squared plus no x's. So I'm going to just skip that. And then plus 2. And you want to set that equal to 0. Again, it's like what we did before, but you're just not stopping. You just need to keep going and actually solve the whole thing. So we're going to subtract the 2 over, divide by 2, and then square root. So your square root of 1 is 1. We just need the plus and minus. And because there's a negative, it's going to be I. So it's plus and minus 1i. So that is 2 answers. You got a positive I and you got a negative I. So that's 2 answers. And then you also had the x equals 4 and the x equals -1/2. And so you just want to check, like, hey, did I end up with 4 total answers? So you should end up with, the answers should equal your degree. So let's try it again. You share my screen and type in this next one. And actually, I'm just going to kind of make changes to what's already there because it's really similar. There we go. So I'm going to click on my zeros. So I've got -2 is one of them. So I'm going to put -2 in the little box. It looks like my exponents are in order. So I'm just going to kind of take all of those numbers. And my remainder will be 0. If it's not, then I made a mistake somewhere. I did get 0. So one of my answers is -2. I'm going to go back and find another one. Now that one's a big old mess. I'm going to talk about that in a second. Okay, and I think this one is too. Yep. So I'm going to click on this one and I see that it's 5. So I'm going to put 5 in the little box. Again, the remainder should come out to, not should, it will come out to 0. Otherwise, you got a mistake somewhere. So again, when I put the x's back in, I'm going to start with 2 less than what I started with because we divided out twice. So it's a 1x squared minus 2x minus 1 equals 0. This does not factor. If this was a +1, it actually would factor, but because it's a -1, it is not going to factor. So instead, we are going to complete the square. You can factor, you can complete the square, or if it's something really simple, you can kind of just solve it like we did this one, but those are your options. Factoring, complete the square, or this is your square root property. So we are going to add 1 to both sides. That'll give us something squared equals 2. And in the blank, we're going to have x minus 1. And then again, just keep going. Like, just don't stop. Just keep on going. We're going to square root both sides. So plus and minus square root of 2. 2 is a small number. You don't have to split that. And then add over the 1. So this is 2 answers. It's 1 plus square root of 2 and 1 minus square root of 2. But I should have a total of 4. So these are my other 2. And then I just want to show you how this matches up with what's on the graph. If you type in 1 plus square root of 2, see how it comes out to 2.4, blah, blah, blah? That's this one. And if you do 1 minus square root of 2, that comes out to this one. I am never going to accept this decimal on a test. You have to actually work it out and get the true perfect answer, the 1 plus and minus square root of 2. So don't think you can just put all those decimals on there. You're going to have to actually work it out. Sorry. All right, let me go ahead and type this one in. So we got negative x cubed minus 2x squared plus 5x plus 10. Okay, so let me zoom in on this a little bit here. So we've got -2, that's one of them. That's probably the only nice one I'm going to get. Yeah, see, that one's an awful decimal. And let's see, there was another one over here. See, that one's going to be an awful decimal as well. So those all have to actually work out. -2 is the only one that I can get here from the calculator. So -2 goes in the little box. I'm going to take all my coefficients. I know I did that pretty quick, but it's just multiplying and adding. And then we're going to put the x's back in. Now I am only going to start with 1 less than this because we only divided out once. So it'll be a -1x squared plus no x's plus 5 equals 0. And we're just going to keep working to solve that. So this one's pretty simple. I'm going to just solve it the same way I did this first one. I don't need to factor or complete the square. It's not that complicated. I'm just going to subtract over the 5. Negatives cancel. And then we'll square root. So you get plus and minus square root of 5. That's 2 answers. And then your -2 is the third one. And that makes sense. We should have 3 answers. And again, I'm just going to show you how this matches up with what's on the graph. If I type in square root of 5, that's 2.233. That's this one. And if I type in negative square root of 5, that's going to be this one. All right, so here, let me go and type it into the calculator. I should have just left the calculator up here. All right, so it is 3x cubed, 5x squared plus 7x minus 13. All right, so let's see. That one, well, that's a third, so I might have to use that. Yeah, that's an awful decimal. Let's see if I got another one. Yeah, that's an awful decimal as well. So these two are irrational. Those are decimals that I don't know what those are. 0.333333 is 1/3. That's rational. I can write that as a fraction. So 1/3 is what I get out of that. And then all my exponents are in order. And again, the remainder is going to be 0. If it's not, then you had a problem somewhere. What is that going to be? 39, a third of third. Okay, perfect. Came out to be 0. So whenever you have a fraction in here, you can always reduce these numbers. In this case, I'm going to divide them all by 3. So that gives us this. And when I put the x's back in, I'm going to start with one less than my degree because I divided out once. So x squared minus 8x plus 13 equals 0. That is not going to factor because 13 is only going to split into 1 and 13. And 13 and 1 is never going to add or subtract to be 8. So we're going to have to complete the square. So when you divide by 2 and square, that gives you 16. Add that to both sides. It's going to be blank squared equals 3. In the blank, we'll have x minus 4, and then just keep going. Just don't stop. So square root, and then add over the 4. So again, that's 2 answers, and then the 1/3 is the third one. And again, I'm not going to waste your time, but if you type 4 plus square root of 3 in and 4 minus square root of 3, that'll give you the weird decimals that the other ones came out. Or I shouldn't say weird, irrational decimals that the other ones came out to, but you can check it that way. All right, this one we should get 4 answers. So let's see, zoom in here. So we get -3. So let me go ahead and put that in a little box. All of our exponents are in order. And our remainder should come out to 0. I may need a calculator here. I don't know. We'll see what happens. So what is that? 87. -3 times 87. I think that is going to come out to -261. We could double check that, but it has to come out to 0. All right. Now I'm going to go back. I need to find another one. And when you look at this graph, it doesn't touch the x-axis anywhere else. But here's the thing. Do you see how it is bouncing at 3 or -3? How -3 is a bounce? That means it's a twin. And so it counts twice. So we can actually use -3 again because the graph bounces there. So again, we're going to end up with 0 is our remainder. And because we divided out twice, I'm going to start with 2 less. You always have to get it down to a quadratic. You have to, divide out until you get it down to a squared. Again, 29 only splits into 1 and 29. So we are going to have to complete the square. It's not going to factor. Most of these don't. If it factored, you'd be able to just look at the graph and see the answers. So majority of the time, it's not. And we're actually expecting imaginary answers for this one. Like we should get I in our answer because this doesn't touch the x-axis anywhere else. There aren't any other real ones. So it should come out imaginary. So divide by 2 and square. We're going to add 25 to both sides. We're going to have blank squared equals -4. In the blank, we're going to put x minus 5 and then just keep going. So when you square root of 4 is 2, but it's going to be 2i because it's negative, and then plus minus. So we get 5 plus and minus 2i. That is 2 answers. Now, with the -3, you do need to write it twice. It's a bounce. It does count twice. And if you don't count it twice, you don't get your total of 4 answers. So I know it sounds weird, but like one answer is -3, and then another answer is also -3. Twins still count as 2 people. However you want to think of that, but you need to end up with a total of 4 answers for that. So you got to write it twice. Right. And then last one, let me share the screen and go ahead and type it in. So x to the 4th, we're missing the cubed, is plus 20x squared plus 64. So you notice with this one, see how it does not touch the x-axis? Where's the graph? There it is. It's all the way up there. The reason it's all the way up there is because of that plus 64 at the end of the equation. It moved up 64. So here's the thing. We can't do a synthetic division. That's not going to work. There is no number that I can put in the little box off to the side because it doesn't touch the x-axis. Every single answer, all 4 of them, are going to be imaginary. So we're going to get 4 answers, and they're all imaginary. So when you're kind of back to the drawing board, like this method is not going to work. Instead, you want to fall back on factoring. So we're going to split it apart. Now, typically there's an x squared here and you split it x and x. Since it's an x to the fourth, it's going to be x squared and x squared. And then we need to split up 64. So I need numbers that multiply to be 64 and add up to be 20. So that would be 16 times 4. They'll both be positive. And then we're just going to set each of these equal to 0. So the first one, if you set this equal to 0, you would subtract over the 16. So if you set x squared plus 16 equal to 0, you would minus over the 16, and then we're going to square root, and you get plus and minus 4i. Same thing with this one. You would subtract over the 4, square root, and you get plus and minus 2i. So did we get 4 answers? Yes, we got 4i, negative 4i, 2i, and negative 2i. And the reason they're all imaginary is the graph did not touch the x-axis anywhere, though. So we had no real answers. They were all imaginary.